Okay, first thing you need to do is mix the electrolyte. So here we are mixing the electrolyte. We have our little bottle of lye in this particular case. We have some sort of a stainless steel knife or spoon or something. In this case I'm using a 1 quart or 1 liter jar, a wide mouth mason jar, and you pour in your distilled water, the right amount for what needs to go in the electrolyzer, and then start mixing the lye into the water. You never pour the water into the lye. It'll practically explode. So to make things safe, you just dribble a few little particles of lye in. And yes, this takes a while, but you just keep dribbling in a few little particles of lye and mix until those particles are gone, and then dribble in a few more and just continue that process until it's done. And if you were doing this properly, you would be using rubber gloves to protect your hands and have goggles on and what have you, just so that any lye that spills would be contained. Always safe. Safety first. So I mention that even though I get very blasé about my safety practices. Don't do that. Be safe. As you continue to mix, you're going to discover that the solution gets cloudier and cloudier, and the temperature starts to rise. The rising temperature is going to help you because the hotter the water is, or the warmer the water, the faster it dissolves the lye. And the dissolving of the lye tends to heat up the water anyway, so that process is going to happen no matter what. The side effect that you need to pay attention to is that as the water warms up, it's going to start emitting noxious fumes. The various hydroxyls and what have you of the lye, as it hydrates, gets vaporized, and that vapor mist kind of comes out into the air. And if you breathe that, it's hard on your lungs. So not necessarily poisonous per se, but you wouldn't want to breathe it. So it's good to do this in a well-ventilated area, or do a little and come back kind of thing, whatever the case may be for your situation. But you do want to not breathe the fumes. Okay, now that the electrolyte has cooled, I can pour it into the machine. We'll try to make sure that it doesn't drip on the machine. Dripping on me is not a big problem because I can just wash my hands. By the way, whenever you're washing anything with lye on it, just wash until the slippery feeling is gone. I'll just pour a little at a time there and watch the electrolyte go into the machine. Now, I'll pour in a little water to make up the difference. I'm making sure that the electrolyte goes all the way. It's now filling these end cells. And just a little bit more water. There we go. Okay. Okay, now we'll take some Teflon tape and wrap it around the threads here, if it isn't wrapped with Teflon tape already. You wrap in the same direction that the threads go, so that the cap, when it's screwing on, tightens the Teflon tape into the threads. If you tighten the other way, it'll tend to push the Teflon tape out of the threads. put enough Teflon tape on that it tightens and seals. In this case, I'm doing about 10 turns or so, and I can vary the amount of Teflon tape if necessary to make sure that the gauge, the pressure gauge, when it's finished, is pointing to the front. So here we go. Put that on there. Turning it around. Now, you only have to tighten it hand tight, and you don't want to push on the fittings here because you don't want to tear the threads open or anything, the seal there. So, here we go. So that's probably actually tight enough, but I'll see if I can go run one more time. If I couldn't go all the way around one more time, then I'd have to take it off and put a couple more wraps of Teflon tape on so that I would, because you don't ever want to go backwards, because it'll take out the seal. Okay, so we're just about, there we go. Does it. Now, again, you don't want to go backwards, so this particular thing here, we go forward. So this will be the fill tube when we're filling it with water. And this is the torch, gas out, bubbler tube. Now the next thing we'll do is connect up the wires, the two wires to the switch, which I disconnected for travel, and also of course you have to disconnect them whenever you take the cap on and off. I just use U-type terminals so I can just slide it under the screw and tighten it down. Now of course with an experimental demonstration like this, I don't have it in a casing, I don't have anything over the terminals to prevent electrical shock and everything. So obviously that's one of the things that you want to do is make sure that you don't touch anything that is high voltage, like the ends of the electrolyzer or any of the capacitor connections or anything like that in the back. The capacitance limits the amperage, so that even if the electrolyzer was shorted out completely, it would limit it to a certain amperage, in this case about 1.5 amps or something. And so that's it. This is a capacitive limited power supply, and this is how it turns on and off with the full wave, with the electronic relay, which is switched by the pressure switch. That's the thing you really need to have it operate as a water torch, because you need to control the pressure. And I found that you want full amperage until you shut it off, and you just turn it on and off to control the pressure, because as soon as you turn it on, it makes gas, makes pressure. As soon as there's enough pressure, you turn it off, no more gas is made, pressure stops. Okay, so there's the machine. Again, this is the check valve for the water fill, and this is the check valve for the gas out. Because what happens when there's gas produced in there and it's warm, it'll tend to condense and cool. So if you happen to have this in a water jug, it'll create a vacuum and it'll suck water back into your machine. That's why this check valve is here, to make sure gas comes out, water does not go in. And in this particular case, I'm going to just tighten this a little bit more and have that pointing straight down, because it makes it easier for everything to work. So the process of putting water into the machine is with a syringe, and you can take and put distilled water into this bottle that came with the machine, and then you can fill the syringe by just sucking water out of the orifice reducer here, just like this. And you can always have a little distilled water near the machine for using it. And then you can just squirt the water right up there into the machine. helpful to have this pointing up, so when it spits back any water, it just doesn't get too much on the machine. And that's how you fill water in the machine. Now, I always recommend pulling the rubber cap back from the top a little bit, otherwise it can stick there and then the plunger ends up sticking and gets pulled out and the syringe is useless. So just pull it like that, and then when you're ready to use it again, you just push it forward to break the seal on the plunger, and you're ready to go. So another thing you must have if you have a water torch is to have a flashback arrestor, at least one. And what this is a 1/4 inch National Pipe Taper nipple that I put a 1/4 inch National Pipe Taper nipple to female to 1/4 inch barbed fitting on, and then I put a 1/4 inch close coupler on there, and then a 1/4 inch to lure, in this case female lure, fitting on the end. And before I screwed these together, I packed this area right in here all full of stainless steel wool, fine stainless steel wool. Now when that is wet, it will quite adequately stop a backfire coming from the torch. So in this particular case, I bought a little lure valve in order to act as the actual valve in order to shut the gas on and off, which it works quite nicely for. And then a person can just have the various hyperthermic needles and the various sizes adjust the amount of flame. Of course, the amount you open and close this valve adjusts the flame as well, the amount of gas that can flow out. And in this particular case, you can just change the needles fairly quickly that way. Now, the bigger the size, the bigger the number on the needle, like this is a 22, and this one here is a 19. The larger the size, the number, the smaller the hole, the little tiny hole in there. So you have to get a little bit, if you buy these needles just at the drugstore or something, or a farmer's supply store is actually better for injecting animals and what have you. Or just get them from Cole Parmer or someplace like you get the lure stopcock, we call it, valve from. So all these pieces here I got from Cole Parmer, and this you can just get from a hardware store, and along with the 1/4 inch vinyl tubing. So there you have a torch, and you have a torch that'll stop a backfire, so the backfire won't go back to your electrolyzer. But this has to be damp. Now normally there's some water moisture coming out with the gas that keeps this damp. So the very first time you go to use this, you have to make it damp. Now, if I'm not using it as a torch, if I'm using it as a bubbler for bubbling water or putting gas, like there's people that, for example, want to treat a wound on their hand or something, and you just put a plastic glove or even a bag over your hand, and then you put the gas tube into the bag. And in this particular case, I just got a male lure fitting that'll just go on here. So now I have a gas end to the hose. So now I can bubble my water. There we go. Turn it on 10 minutes and come back to bubbled water. There we go, bubbling away. So now we're putting more water in. The ideal height of the water should be so that the float is floating halfway up on its stem, or as high as just about the top lip of this T here. Now we'll do some experimenting with the flame. which the first thing is to put the torch handle on, and I've already got one of the needles affixed there. In this case, the number 19. Let's put the 20 on. Okay. And helps to plug the hole. There we go. Building pressure. And we have pressure, so now we'll open up. And what we want is for the light to open enough so that the light is still flashing. When the light goes steady, it would be too much. And when the light goes steady, then you'd start to lose pressure. So essentially what you do is you can open it up as far as you want to and still not be losing any pressure. This is odd. Looks like this particular needle is plugged. Okay, there we go. You can hear the little the sound it makes. So I'll need to figure out what's wrong with that other needle. So we have a water torch flame. Quick way to clear out a plugged needle is to put it on the syringe and spray the water through it. Nice and cleared out. Okay, there's the number 20, and we'll get ourselves adjusted here so that we have gas pressure without gas maximum, without losing pressure. So we want more gas volume. We can turn that on. We can jump the capacitors. So now the capacitors are out of the system. It's just direct current. And we can open up this torch. We can pretty much have as much gas volume as we want. Up to about 200 liters per hour. You always want to shut the water torch off really fast so that the flame, because the flame is burning back at about 20 feet per second in open air, but as soon as it enters the, so you have to have the gases going faster than 20 feet per second as it comes out the orifice, or the flame will burn back into the torch. Once the flame burns back into the torch, it goes into an enclosed area, which accelerates the flame to about 5,000 feet per second. That's what makes the bang. So theoretically, the backfire arrestor should stop it, but in theory, that's just theory. Hopefully it works that way in practice all the time too. But nevertheless, if you shut the torch off fast, then the backfire only goes back to here, never any problem. Okay, here's the ER50 that was won by the fellow in India. It's a grid plate ER50. And transparent even in the T and the end caps, unlike my regular ER50s and or the commercial ones. It is set up as a water torch, and I'm just giving a little video now as to the operation of it, so that I can send it to the two winners of the water torches, so they know how to operate them properly. When you go to turn on a water torch, or the electrolyzer itself, there's various timings that you can use, and so we just turn it on. As long as it's producing gas, this little red light is on here. So in this particular case, the gas is being generated in the cells and coming to the center tower. Right now the liquid level is down here, and the gas comes up and out this particular hose here. Through a check valve. I recommend putting the check valve in place. This one particular one, they call it 1/4 inch Canar check valve. And then the hoses go out through the backfire arrestor. Now, if you're just using the ER50 for health, you don't generally need a backfire arrestor. You might want to put a bubbler in, but otherwise. And then at the end of the backfire arrestor, I have a hose going to where I can bubble the water, so I can drink the Brown's gas bubbled water, or bubble the water for whatever need you're doing. Okay, so that generally is the Brown's gas bubbled water normal situation. So what we're going to do now is first we'll shut off the. I don't need a special switch, because this particular timer switch has a shut off button on the bottom, so I don't need an additional switch for that. And what we'll do is we'll one-handed here maybe disconnect this hose. So what I've done is I have a lure fitting that can fit onto this particular lure fitting that goes on the end of the torch backfire arrestor, which I show another video of how to make these particular things. Essentially, you can see it's just these pipe fittings. I put a very fine mesh stainless steel wool in there, and the lure fitting 1/4 inch National Pipe taper thread to female lure fitting on the end. And in order to make this backfire arrestor absolutely secure, or like it'll stop a backfire, then what you do is you take some water and you squirt it into the end here. So you put water in there, and then you just shake out the excess water so that it makes that stainless steel wool wet. As long as that stainless steel wool is wet, it'll reliably stop a backfire that's going in on this side. So then the backfire doesn't go back to your electrolyzer, which really isn't designed to withstand backfires. So the first thing you want to do if you're going to be operating a torch is to make a backfire arrestor. The next thing is that you need the torch itself. So here we go. We have the torch tip on. So you can just take off the bubbler hose and put the torch tip on. This particular lure stopcock has a female and female end, so a person can change out the torch tips. The torch tip can be changed for larger or smaller ones. These are called blunt end syringe needles, so they can just be put on there just like that, and you have yourself a torch. Okay, now we have a backfire arrestor and a torch. The next most important thing is the pressure switch, because you never want, now that the gas production is shut off, if you turned on the gas and there was not a pressure switch, the pressure would just continue to rise and rise and rise until something burst. In this particular case, the pressure switch is set for 1 psi. Now there's a little rubber cap on the top that allows you to take an Allen key, and I don't know if you can see down in there or not, but anyway, you can take an Allen key and you can actually adjust the pressure up or down. So there, we just adjusted the pressure up. Now what I'm going to do to bring it back down, turn the gas down, shut the gas off, turn the gas on, and there it is. I just happened to turn it down enough, right to there, but otherwise a person could turn it down a little bit more, and it would only rise to the place where you have it set. Okay, there we go. And that's how you adjust these particular type of pressure switches. Now, one thing you want to do too with these particular plugs is you want to cut the little knobby off. So there's actually a hole in the top. That way any hydrogen gas that comes through the diaphragm doesn't build up a pressure in the separate container and make the switch unreliable. In this particular case, when the gas is being produced, that light goes on. So, back to where we are here. What we're trying to do is get the maximum gas production out of the torch without lowering gas pressure. Okay, so I've closed the valve, gas pressure is rising, torch shuts off. So now what I'm going to do is I'm going to, oh, there it is, perfect. You see that light flashing? And us not losing pressure. That's where you want to be. Now the torch is producing the maximum amount of gas that it can produce because you're not losing pressure, and that light is just flashing, mostly staying on but just flashing. So at this point a person could light the flame. Backfire Arrestor did not work because I hadn't put water in it yet. And what happened was this valve blew off. Okay, I had a backfire. It blew off this cap, and I don't know if it wrecked the switch or not, but the switch wasn't working reliably, so I exchanged it for another new one. And this happens to be one of my upgraded ones, which has the steel base and the Teflon diaphragm inside. So that's all good, and we are ready to go again. And what we do, I also added an additional capacitor at the back. So there's 3 of them back there now. Just wired it in parallel with the other ones. So there's now 3 capacitors, and the wiring is all as per the instructions that I have posted on the website. Let's see if we can take a look here just quickly at the wiring. So at the back we have the power cord coming in. All the neutrals get hooked together, and all the grounds get hooked together, and then the power wire that comes in goes first to the switch, to the timer switch, and then the power comes out of the timer switch and goes to the main relay, and from the main relay then it goes to the full wave bridge rectifier, which goes to the electrolyzer and back to here, and then the neutral wire goes out. So that's the main circuit. And the float switch circuit starts on the main relay on the side that has power. As soon as the switch is turned on, goes up one wire and down the other wire to the neutral. So as long as it goes from the power to one side of the AC signal, from the other side of the AC signal, then it goes up to the float switch and then down to neutral. So when the float switch turns on, it allows power to go across the signaling part of the relay, which turns on the main part of the relay. And when the main part of the relay turns on, then the full wave bridge rectifier gets power, which makes the AC into DC for the electrolyzer, and on this side comes the positive wire, and on that side goes the negative wire. So pretty simple, straightforward. But what was happening is, for that size of torch tip that I was using, which the first one I was using was a number 8. Let's see, was it 18? Yes, it was an 18, and that was too large. And what was happening was the torch tip was backfiring into the torch handle there, and it had 5, 6, 10 backfires or something, and it wasn't too bad. Like the Backfire Arrestor was holding it, but this was a brand new Backfire Arrestor which I hadn't made wet yet. I hadn't taken a syringe and put the water in it like I said I was going to do, and so it backfired through there eventually, and backfired into the ER50, which the ER50 is fine. It just, the float switch and pressure gauge can be sensitive to the sharp pressure spikes of the backfires. So it turned out that the pressure switch may have gotten damaged. I'll check on that later. But in the meantime, I switched it out, and so we can continue. Now, I've done a couple of things. The first thing I did was I changed this down to a number 20 size. Now, the smaller the number, the larger the orifice. Okay, so a 20 is smaller than an 18, which I had on there before, and I noticed that the 18, it did hold when I had two capacitors on. It was just barely keeping enough flame on there, but it was tending to make the torch tip hot. It was getting a red glow around the end of the torch tip. That told me that the gas velocity wasn't great enough for that size of orifice. So you have to either use a smaller orifice or increase the gas production to get the gas velocity up. So I've done both. I reduced the size of the orifice, and I increased the gas production by 1/3 by adding an additional capacitor. So we won't have any more problem with that. So let's see if I can now light this torch tip. First thing we'll do is we'll turn on the electrolyzer, and it already has pressure, so now we will open up the pressure again. Yeah, it's really hard to do this one-handed accurately, because it gets right to that point, and there we go. So what you want is it mostly to be on, so the light mostly on, but not losing pressure. Now I'm losing a little bit of pressure, so I turned it off a little bit, and now I'm turning it on again a little bit, watching the light. Now, just a note, it actually, if you use a voltmeter, a DC voltmeter, and you can put it right over here on this side, there's a big blank area there, you can watch the needle wave, and as the needle kicks back and forth, it's like that light, and it makes it really easy to see when you're getting maximum gas production. So I'm opening this up, and I think we're right on. It's just ever so slight of a flash every once in a while, and it's holding pressure. So I listen, I can hear the gas production
hissing. I don't know if you can hear it in the camera. But anyway, there we go. That's the maximum gas production that can be produced with the capacitive amperage limiting. Now, I'll set the torch down. Doing things one-handed. Okay, and we'll light the torch. Oops. And there we go. A really nice ground gas flame. It's not making the torch tip red, so there's plenty of gas velocity. Nice, long and thin, relatively clean. As it gradually gets a little bit of lye on the tip and stuff, that flame will turn yellow, more yellow. So there we go. It helps if you're going to do things one-handed. I guess I should make a stand to set it in, and then I would be able to light it. But that is how you light the torch and use the torch, and shut the torch off. As you've already seen, make sure that the Backfire Arrestor stays wet, so it'll reliably stop the backfire. When you are there's a couple of things I wanted to point out. For maintenance purposes, you can clean the torch orifice generally, like if it gets plugged with water or debris of some sort, a buildup perhaps of residue. You can take your syringe and fill it full of water and stick the needle on there, and then just squirt water through it. That'll tend to clean it. Or air, in some cases, air would be enough. So that's one way to clean it. The other way is you can use little teeny drill bits that are called jeweler's bits, and you can actually, they make them small enough that you can go right into that orifice, that tiny little orifice that's in the middle there, and clean out your torch tips. Generally, you don't have to clean them very much, because the only time they'll actually get dirty is if you're soldering and get some flux on the tip or something like that. Ground gas tips stay clean for a very, very long time. Okay, if you're taking the cap off the torch, you'll need to disconnect these two screws here and just move those wires back. Obviously, unplug it first, and that should do it. You pretty much should know how to operate the torch. One additional thing here I can think of at the moment is that you can, when you have a situation where it's a torch like this, actually bypass the capacitors. So you can get maximum gas production out of the torch. Like, my timer just shut off, I heard the click. And the way that you do that, clip the test clips between the two terminals of one of the capacitors, any one of them, and what that does now is allow the electricity to bypass the capacitors, and you don't have the capacitive amperage limiting anymore. But because of the pressure switch, you don't really need it. So now what will happen, if we turn it on, we can actually open this up and have a large amount of gas production, which allows us to, you can see every time that amperage hits the electrolyzer, it's making foam and all that kind of stuff. But it holds the, I don't know if you can hear the hiss, it holds the gas at a much higher velocity, much higher gas production. But also makes a lot of foam, and the liquid level rises in the electrolyzer quite a bit. You know, that foam that's happening in there. Now, foam, we have to defoam the electrolyzers, and I'll be teaching you guys how to do that more after as well. The foam is bad because the foam tends to fill up in the cells and eject the fluid. So in this case, when we're using a lot of amperage, the liquid level starts to rise in the tower, And if it's rising in the tower, that means it's being ejected out of the cells. Here's an interesting thing. I don't know if we can see. You can see that part of the gas is going toward the tower this way, and part of the gas is going out the pressure relief tubes that way. Anyway, as the liquid level rises in the tower, that means it's being ejected, and that means there's less and less liquid level in the cell tubes, which makes them less efficient. So that's just one thing to watch for when you're trying to increase gas production by increasing amperage, is that it can only take just so much amperage, and it kind of ejects the pressure of the gas being generated, and the foam ejects the liquid right out of the cells. So there you go. Have fun. It works well, as long as you remember to put water in the Backfire Arrestor. Oops.